Hello everyone, I am Miss Priyanka Sanjay Late, working as lecturer at Mula Education Society's Mula Rural Institute of Pharmacy, Sone. In this presentation, I am going to discuss topic that is adulteration and drug evaluation. This topic we will discuss for first year D Pharmacy student, part 2nd. In previous presentation, we have already discussed the two classifications type. First one that is the organoleptic evaluation and second one it is the microscopical evaluation. In this presentation, we will discuss the content, physical evaluation in that moisture content, viscosity, melting point, optical rotation, refractive index. Then the next chemical evaluation and biological evaluation. Firstly, we will discuss physical evaluation. Physical standards are to be determined for drugs wherever possible. They may help in evaluation specifically with reference to specific gravity, density, optical rotation, refractive index, melting point, viscosity, and solubility in different solvents. A few of them are described below. First one, moisture content. The percentage of active chemical constituent in crude drugs is mentioned on air-dried basis. Hence, the moisture content of the drug should be determined and also be controlled to make the solution of definite strength. The moisture content of a drug should be minimized in order to prevent decomposition of crude drugs, either due to chemical change or due to microbial contamination. The moisture content is determined by heating a drug at 105 degrees Celsius in an oven to a constant weight. For the drug containing volatile active constituent, the toluene distillation method is followed. Crude drugs with limits of moisture content. First, crude drugs allows moisture content in percentage weight by weight not more than 10%. Second one, digitalis not more than 5% weight by weight. Third one, ergot 8 not more than 8% weight by weight. Fourth one, acacia not more than 15% weight by weight. Fifth one, starch not more than 15% weight by weight. Second, viscosity. Viscosity of liquid is constant at a given temperature and is an index of its composition. Hence, it can be used as a means of standardizing liquid drugs. The following are the suitable examples. First one, liquid paraffin. Kinematic viscosity not less than 64 centistokes. And second one, pyroxylene. Kinematic viscosity 1100 to 2450 centistokes. Third one, melting point. It is one of the parameters to judge the purity of crude drugs. In case of pure chemicals or phytochemicals, melting points are very sharp and constant. Since crude drugs from animal or plant origin contain mixed chemicals, they are described with certain range of melting point. The purity of the following crude drugs can be ascertained by determining their melting points in the range shown against each of them. Melting point range for few good drugs. First drugs, colophony, the melting point 75 to 85 degrees Celsius. Second one, kokum butter, the melting point 39 to 42 degrees Celsius. Third one, coca butter, melting point 30 to 33 degrees Celsius. Fourth one, beeswax, the melting point 62 to 65 degrees Celsius. Fifth one, anhydrous wool fat, the melting point 34 to 40 degrees Celsius. Next one, fourth, optical rotation. Certain substances are found to have the property of rotating the plane of polarized light in pure state or in the solution. Thus, they are described to be optically active, and this property is known as optical rotation. Plane of polarized light may be rotated towards right, is called as dextrorotatory, and the plane of polarized light may be rotated towards left, is also called as levorotatory. Normally, the optical rotation is determined at 25 degrees Celsius using sodium lamp as the source of light. Following is the list of few drugs of pharmacognostic origin with their optical rotation. Optical rotation values for few good drugs. First good drug, caraway oil, angle of optical rotation plus 70 degree to plus 80 degree. Second, castor oil, not less than plus 3.5 degree. Third, clove oil, 0 degree to minus 1.5 degree. Fourth, honey, plus 3 degree to minus 15 degree. Fifth, eucalyptus oil, minus 5 degree to plus 10 degree. Then the next, refractive index. When a ray of light passes from one medium to another of different density, it is bent from original path. Thus, the ratio of the velocity of light in vacuum to its velocity in the substance is determined as refractive index of the second medium. Depending upon purity, it is a constant for a liquid and can be considered as one of the criteria for its standardization. Refractive index of a compound varies with the wavelength of the incident light, temperature and pressure. Refractive indices of the following compounds are for sodium light and at a temperature of 25 degrees Celsius. Refractive indices of some phytoconstituents. The first drugs, RHS oil, the refractive index 1.4678 to 1.4698. Second drugs, caraway oil 1.4838 to 1.4858. Third one, castor oil. Refractive index is 1.4758 to 1.4798. Then the fourth, clove oil. The refractive index is 1.5300 to 1.5310. As mentioned, earlier evaluation of drug basically needs its identification and can be done by morphological and microscopic characters. Many a times the drugs identified by its diagnostic characters is of substandard quality due to either faulty collection or incorrect storage. Thus, to prove its acceptability as a drug, the following test can be applied to it wherever possible. First one, ash content. Second one, extractives. Third one, volatile oil content. We will discuss one by one. Then the first one, ash content. The residue remaining after insertions is the ash content of the drug, which simply represents the inorganic salts naturally occurring in the drug or adhering to it or deliberately added to it as a form of adulteration. Therefore, it is a criteria to judge the identity or purity of good drugs. Total ash usually consists of carbohydrate, phosphates, silicates, and silica. For the examples, drugs allows total ash contains 5% weight by weight. Second one, Ashoka, total ash value 11% weight by weight. And third one, Clove, the total ash 7% weight by weight. Acid insoluble ash, which is a part of total ash insoluble in dilute hydrochloric acid, is also recommended for certain drugs. Adhering dirt and sand may be determined by acid insoluble ash content. For the few drugs, for the first drug agar, acid insoluble ash, the percentage weight by weight not more than. So in that first drug agar, not more than 1% weight by weight. Second, belladonna, acid insoluble ash value not more than 3% weight by weight. Third one, cannabis, not more than 5% weight by weight. Fourth one, cardamom, not more than 3.5% weight by weight. And last, fifth, clove, the acid insoluble ash value 0.75% weight by weight, not more than 0.75% weight by weight. Then next, extractives. Many a times the extract obtained by existing crude drugs are indicative of approximate measures of certain chemical constituent they contain. Taken into consideration the diversity in chemical nature and the properties of contents of the drugs, various solvents are used for the determination of extractives. The solvent used for extraction is in a position to dissolve appreciable quantities of substances desired. The following are various methods used to find out the extractive values. Then next, water soluble extractive. This method is applied to drugs which contains water soluble active constituents of good drugs such as tannins, sugars, plant acids, mucilage, glycosides, etc. For the examples of drugs, first drugs allows in that content water soluble extractive not less than 25% weight by weight. Second one, linseed. In linseed water soluble extractive not less than 15% weight by weight, and third one sennaluse, not less than 30% weight by weight. Then next, alcohol soluble extractives. Alcohol is an ideal solvent for extraction of various chemicals like tannins, resins, etc. Therefore, this method is frequently employed to determine the approximate resin content of drug. It is also an official method for assay in case of myrrh and asafoetida. Generally, 95% ethyl alcohol is used for determination of alcohol soluble extractive. In some cases, diluted alcohol may also be used depending upon solubility of constituents in good drugs. The limit for alcohol soluble extractive is applicable to following few drugs. Alcohol soluble extractive values of some good drugs. First drug allotes, not more than 10% weight by weight. Second benzoin, containing 95% alcohol. So alcohol soluble extractive not less than 90% weight by weight in simbenzoin and not less than 75% weight by weight of Sumatra benzoin. Third one asafoetida, it contains 90% alcohol. So alcohol soluble extractive is not less than 50% weight by weight. And fourth ginger, it contains 90% alcohol. The alcohol soluble extractive is contains not less than 4.5% weight by weight. The next, alcohol insoluble extractives. Alcohol insoluble extractives values as applicable to some resinous drugs are given in below. The first drug myrrh, alcohol insoluble extractives not more than 70% weight by weight. Second one benzoin, it contains alcohol insoluble extractive not more than 24% weight by weight. The next, ether soluble extractives. Two types of ether soluble extractives. Values determined for evaluation of good drugs are volatile and non-volatile ether soluble fraction. The volatile ether soluble extractive represent volatile oil content of the drug. Whilst non-volatile ether soluble extractives represent resin, fixed oils or coloring matter present in drugs. For example, the drug's first capsicum contains capsicum. Limit for non-volatile ether soluble extractive is 12% weight by volume, not more than 12% weight by weight. Second one, melfun. The limit for non-volatile ether soluble extractive is not more than 1.5% weight by weight. And third, linseed. It contains limit for non-volatile ether soluble extractive not more than 25% weight by weight. The next, volatile oil content. Efficacy of several good drugs is due to their adulteration principles, that is volatile oils. Such good drugs are standardized on the basis of their volatile oil contents. A few examples are quoted here. The first drug caraway, the volatile oil content not less than 2.5% weight by weight. Second, fresh lemon peel, the volatile oil content not less than 2.5% weight by weight. And third one, clove, volatile oil content not less than 15% weight by weight. Different chromatographic techniques such as thin layer chromatography, in short TLC, then high performance liquid chromatography, in short HPLC, then gas chromatography, column chromatography, gel permeations chromatography, affinity chromatography, as well as techniques like IR, NMR, spectrophotometric method, radioimmunoassay are used very frequently for physical evaluation of good drugs. The parts of the organ or organs other than those named in the definition and description of the drugs are defined as foreign organic matter. The maximum limit for the foreign organic matter is defined in the monograph of good drugs. If it exceeds the limits, deteriorations in the quality of the drugs takes place. The limit for foreign organic matter is specially mentioned for natural drugs of vegetable origin. Then next classification, chemical evaluation. It comprises of different chemical tests and chemical assays. The isolation, purification and identification of active constituents are chemical methods of evaluation. Quantitative chemical tests such as acid value, saponification value, etc. are also covered under this technique. Some of these chemical tests are useful in evaluation of resins, in bracket acid value, bracket complete, balsams, in bracket acid, saponification and ester values, bracket complete, volatile oils, in bracket acetyl and ester values, bracket complete, and gums, in bracket methoxy determination and volatile acidity, bracket complete. The preliminary phytochemical scanning is a qualitative chemical evaluation which indicates the spectrum of chemical constituent present in a plant drug. The successive solvent extraction of a drug is carried out with petroleum ether, benzene, solvent ether, chloroform, ethanol and water in succession. The chemical tests also help in proper identification of varieties of the good drugs. The solutions of lead acetate or lead subacetate are used specifically for the chemical identity of gums. The conventional titanometric estimations as applicable to estimation of alkaloids from good drugs, ester and aldehydes, contents of volatile oils, gravimetric methods, etc. are the techniques of chemical assays. The estimation of chief constituent or group of active constituent is an integral part of chemical evaluation. For example, total senosides in senna, morphine in opium, citral in lemongrass oil, eugenol in clove oil, eucalyptol in eucalyptus oil, water soluble alcohols in ergot, propane alkaloids in belladonna, imitin in ipecac, reserpine and riscinamide in raulfia, quinine in cinchona, etc. Then next classification, biological evaluation. When the estimation of potency of good drug or its preparation is done by means of its effect on living organisms like bacterial, fungal growth or animal tissue or entire animal, it is known as bioassay. This method is generally called for when standardization is not adequately done by chemical or physical means. In other words, bioassay is the measures of sample being tested capable of producing the biological effect as that of the standard preparation. Such an activity is represented in units known as international units, that is IU. The specific biological activity contained in each international unit of few drugs is mentioned as follows. The first digital is in one international unit is contained in 76 milligram of standard preparation. Second, vitamin A in one international unit is contained in 0.344 milligram of standard preparation. Third one, vitamin D. One international unit is contained in 0.025 milligram of standard preparation. Fourth one, heparin. One international unit is contained in 7.7 milligram of standard preparation. Next, methods of biological assay. There are three methods of biological assay. First one, toxic method. Second one, symptomatic method. And third one, tissue methods. In that, the first and second, toxic and symptomatic methods. In toxic and symptomatic methods, the animals are used. Then third methods, that is the tissue methods. Whereas in tissue method, the effect of a drug is observed on isolated organ or tissue. Among the drugs that are subjected to bioassay are cardiac glycosides, vitamins, hormones, saponins, anthracene glycosides and antibiotics. In bracket, microbiological assay. Thank you.